In this lab, we are going to find the density of many different objects by first measuring those objects as masses and then calculating their volumes and dividing those two quantities. What we're going to end up finding is that mass is very easy to measure, whereas volume can be a little more difficult. We can use a couple different methods, and really the goal of this is to have you analyze those different methods, see the benefits and the drawbacks of those different methods. And now I'll go through a couple of those volume methods in this video. So for our first method of measuring volume, we would end up using a ruler to measure the sides of an object and then use some simple geometry to calculate the volume. Take, for instance, this cube, but this could really be used on any rectangular prism. The way we would calculate volume of a cube is we would measure each side. I'm going to call these sides side A, side B, and side C. Oftentimes you'll hear these referred to as length, width, and height, but in reality we're just looking at all three sides of the object. Now, volume of any rectangular prism is pretty simple. You just take each of those sides and you multiply them together. So if we know the length, the width, and the height, they're all, say, 2, 3, and 4 centimeters in that order, I would do 2 times 3 times 4, and that would give me that volume. So cubes and rectangular prisms are pretty simple. If we say look at a cylinder, we do have a few cylinders in this lab, we're going to have to use a different formula. And really the two pieces of information we need here are the radius of the cylinder and the height. The radius, to make things easy, what we'll do is we'll measure first the diameter, so the widest point of that circular face, and we'll cut it in half. So if we measure from one end to the other and we get the diameter, we'll want to divide that by 2 to get our radius. The other quantity we'll need is the height of the cylinder. I'll draw that over here. So we want to get that height as well. And our formula for calculating this, let me separate these out, is the volume, V, equals pi times that radius squared times that height measurement. Now, pi, if you can't calculate, if it's not in your calculator, just use 3.14. When we end up squaring that radius, know that you could just multiply by the radius twice. That would give you the same result. And height is whatever you measure this in. And our last object is going to be a sphere, as shown by this circle on the board. For a sphere, we again need that diameter, and diameter for a sphere can be a little bit difficult to measure. You really have to measure at the widest part of the sphere. So really measure the widest part of the sphere to get that diameter. And again, just like with the cylinder, you want to divide by 2 to get that radius. Now we only really need that one measurement because the volume of a sphere is the equation 4/3 times pi times r cubed. Now, to make things easy, if you're not comfortable using fractions and pi in your calculator, you can plug in a couple of different numbers. For 4/3, to make things simple, you could plug in 1.333. For pi, you could plug in 3.14, like we did with the last problem. And for r cubed, if you just want to multiply by r 3 times, that will give you the same result. So these are 3 different equations on how to calculate volume for objects just through measurements with, say, a ruler. Also note that all of our measurements should be in centimeters, which would give our final unit for all 3 of these as centimeters cubed. Now, we know from our classes before that centimeters cubed is equal to 1 milliliter. So when it comes to volume, if we calculate in centimeters cubed, we can alternately call that milliliters. So that's really the first method for calculating volume. Our second method of measuring volume is pretty simple. It's called the water displacement method. What we'll do is we'll take this graduated cylinder, fill it about halfway or so with water. We'll measure how much water it is initially. We'll then drop in our object. In this case, I'm going to use this silvery cylinder, and we'll see how much the water rises. So however much that water rises is how much volume is in this silvery cylinder. So I'll get my initial reading of water. I already did this. We're at 51.5 milliliters of water. I'll drop in my silver cylinder, and I'll see that my final volume is at right around 57.1 milliliters. So the difference in these two volumes is how much volume is in that cylinder. When I do this math, I should get 5.6 milliliters. And in other words, that silver cylinder takes up 5.6 milliliters of space. And now the last part of this is just measuring that mass. This is pretty simple. All we have to do is use one of these balances. These are pretty simple. All you have to do is lift the lid, and with your scale reading 0.00 grams, just place your sample on, and you'll see this scale reads that this silver cylinder is 14.89 grams. And that's really all there is to mass. So now that we have the mass and the volume of this silver cylinder, we can actually use those two measurements to calculate the density. If I take the mass of my silver cylinder, 14.89 grams, and I divide it by the volume, 5.6 milliliters, I can calculate that density. However, be careful. We know that our mass has 4 significant figures, whereas our volume measurement only has 2 significant figures. So our final answer will be limited to 2 significant figures. When I perform this operation, I'll find that the density of my substance is 2.7 grams per milliliter. Now, we should be able to use this information to identify our material. While some densities between materials are similar, this 2.7 gives us a pretty good idea of what material we're dealing with. The last part of your lab, you'll be looking through a list of materials and their densities and figuring out what these different materials are made out of.